All right, I think we are recording here, so we can kind of get started. Welcome to probably your first attempt here at vodcasting. I think the other class has gotten to hear this a couple times, but this will be your first time, and that'll be all right. You're ready to go. There was a couple things that you needed to print off. This first worksheet, an accumulation function worksheet, you needed to print off. If you were unable to get that printed off, that's fine. You can just take some notes, and that'll work out just the same. Otherwise, if you don't watch this until you come back to school, you can certainly stop in my room and grab a copy of it too. I have them all. So to get started though, this worksheet it's chopped off a little bit of some of the writing there, so I'll fill that in a little bit for you. But it's called an accumulation function worksheet, and so we're going to be accumulating area today with this. So getting started, consider a function. And this function goes from a to x. So we're going to be plugging in some values. And we have the function is 1.5 dt, which you can see below is sketched in there at 1.5, y equal to 1.5 in there. The function f measures the signed area under the graph of y equal to 1.5 from a to x. And then there's the piece that's missing. It says, recall that if x is less than a, the value of f will be negative. We'll consider several such functions, each using a different lower limit of integration, and so that's where we are headed. And I can't scroll. I have to come back to that to scroll down a little bit more. All right, so I'm gonna help you fill in some of the values here, and let you fill in some of the values on your own. And even though we're not in school, the bell's still dinging. All right, first one. We see that we have an x value down here of 0. And we go from 0 to x. So if I plug in 0 for that x, so it's going to look something like this. You don't necessarily need to write this down, but just kind of showing you. If I go from 0 to 0, think about how much area have we accumulated underneath this curve. If I go from 0 and stop at 0. Hopefully you're going, well, we haven't gone anywhere, so we haven't accumulated any area, and you would be correct. So I'm going to fill in a 0 there. The next one, if I go from 0 to 1, and I'm just going to scribble over the top of that. If I go from 0 to 1, here is the area that I'm looking at. How much area have I filled in? Hopefully you're coming up with 1.5. Now, if you're a little unsure how we're coming up with that, we're just taking our width 1, our height 1.5, I can't draw a straight line, and multiplying them, 1 times 1.5 to get 1.5. So, onwards. How about the next one there? If I go all the way to 2, now how much area have I accumulated from 0 to 2? I've accumulated 3. And going to 3, I've accumulated 4.5. Each little additional rectangle, if you will, is 1.5 units. All right, hanging in so far? All right, now let's go the other way. Now I'm going to accumulate from 0 backwards to -1. So if I have, and I'm going this way now, what's that going to be? Well, you might be thinking, well, that might be a -1.5 that we've accumulated. And that would be exactly right. And -3 and -4.5. I'm kind of running out of room there. Scroll down a bit more. Oh, I don't like that. Let's not do that. Unwind. There we go. I'm learning too. All right. So down here is -4.5. Okay, hanging in there on all that. I'm going to give you a moment to complete those last two tables. You can probably just hit pause here even for a moment. But think about starting at 1 and going back to 0 is that first one. If I start at 1 and I go back to 0, yeah, that's also going to be -1.5 because we're going backwards. And so that's going to adjust your values just ever so slightly. So I'll give you a moment to do those tables. Actually, just hit pause and complete those two tables because we're going to need them here in a moment. So hit pause now. All right, hopefully you remember to hit play again so that you're back with me. And what we're going to do next is, at the very bottom there it says graph the 3 functions. So what we're going to do, I'm going to pick a color about orange? That might show up over the top of all of them. What we're going to do is we're just going to end up plotting those points. So I'm going to plot 0, 0. The next point is 1, 1.5. 2, 3, 3, 4.5. That's pretty close. 1, -1, excuse me, -1.5, -2, -3, -3, -4.5. And I'm sure that I'm not going to be able to draw a very straight line here, but not too bad. We see a straight line. Go ahead and do that with the other two functions. Real quick, plot those points and hit pause there. Again. And as you come back now, and we've hit play again, I hope. Can you hear me? Anyhow, what do you notice about those three lines that you have plotted in there? Well, hopefully you notice that they all are lines that are parallel. Specifically, how are they parallel? What is their slope? Hopefully you're saying, well, the slope is 1.5. Each of the y-intercepts is just different. So hang on to that. This table idea, some of those ideas we're going to make use of today in the PowerPoint here. We're going to learn some rules, if you will. But this idea of being parallel, this idea of just having a different y-intercept, we call this a C value, a little bit different C value. We're going to talk about that a little bit more the next time I see you. So with that, I think that we're good with this handout. So we'll see if I can clear everything off. I got to do some magic. Hit that. Oops. And we're going to go to the PowerPoint next. There we go. I think we're doing all right. And today we're doing definite integrals, section 5.3, definite integrals and antiderivatives. And I just think this was a fun picture that was with a set of PowerPoints that I make use of. So let's move forward. We're going to talk about some properties of definite integrals. If you have your book handy, that might be useful. We will get into average value and the mean value theorem the next time that I see you. And hopefully by doing some of this today and in the next couple days, we're really going to start tying first semester stuff in with what we're doing now. So on page 285 in your book, you can take a look at all these rules. You don't need to be writing them down. And we'll just kind of briefly talk about them a little bit in light of that accumulation function worksheet we just did. And we'll go from there. So here is the first rule. And it just says if I go from A to B, that's the same as saying the negative of B to A. That really just ties in when we said from 0 to 1 and we said from 1 to 0, those were just opposite values. From 0 to 1 we had 1.5, and then from 1 to 0 we had negative 1.5. And so that's what that little rule is talking about a little bit. Second rule, maybe, is it coming? There we go. Second rule says if I start at A and end at A, I've accumulated 0 area. Yep, that works. Third rule. This is probably the one that looks the trickiest, but really all that is going on here, just like when we were doing derivatives, if I had something that said 2x cubed and I found the derivative of that 2 just hung out in front, and then I just found the derivative of x cubed. The same can be true here. I'm just going to find the antiderivative of f. I'm going to integrate f, and that k, that 2, that 4, whatever that constant is, can just kind of hang out in front, and it will be equal either way. All right, rule number 4. Take a look at that for a moment. Does that make any sense? Well, hopefully it does make sense. It's the same rule that we used, again, with derivatives. I could have x squared plus x cubed, and I can find the derivative of x squared, I can find the derivative of x cubed, just as separate things. That's what this is saying, is that I can find the definite integral of f and the definite integral of g just as separate pieces, and that life will still move on just okay. And the last one that we're going to talk about here, read this one. And I know some of you are going, I don't even want to read it. There's so much there, but it's okay. We go from A to B on the F here, and then we go from B to C, and then we go from A to C. Well, what does that look like? Well, here's a handy dandy graph. If I start by going from A to B, then I accumulate area from B to C, what have I ended up doing? I've ended up accumulating area all the way from A to C. All right, so that one does make some sense too. All right, hanging in there, jotting down some questions, some notes. I have 3 examples that are going to help you today in doing your assignment over these types of problems, and they're pretty quick problems, so hang on and let's have at them. So I got 3 pieces of information up there. 2 pieces of information about F, 1 piece about H. F, I know something about from -1 to 1, and I know something about 1 to 4. H, I know something about -1 to 1. So if I want to figure out from 4 to 1, which of those 3 are going to help us out? Hopefully you're looking at it and going, oh, there's something there about 1 to 4. Well, how does 1 to 4 relate to 4 to 1? Well, remember that it just is the opposite. 4 to 1 just is working backwards, accumulating negative area. This is like saying a -2, if you will, to get a +2. Okay? All right, moving on. So 1 done, 2 to go. Next one. This time I'm going from -1 to 4. Which of those 3 are going to be useful for us? And again, identify that we're using F from -1 to 4. Well, this time we need not only from -1 to 1, but also then from 1 to 4. That's that last fifth rule there, where from A to B and B to C gives me A to C. So I'm going to end up just adding 5 and -2. And so that is my accumulated area. All right, final problem. Final problem says from -2 to 2. Well, I looked at all my values here and I don't have anything about -2 to 2. H. Okay, well here's an H, so I can make use of that one. But what about that -2 to 2? Is it enough to just say that I can double that? Because 2 seems to double 1. What? Well, here is that 50-50 rule, I think that is. Ask Brian. Anyhow, no, that isn't enough. Because remember that every shape isn't going to just double as we go. We can have parabolas, we can have cubic functions, we can have square root functions, and we can have any combination of all of those. And so you can't just assume that just by doubling the value you can kind of double your space, if you will. So that's not going to quite work out. So that's 3 examples to help you get started on your assignment today. And that's all we needed to go over from an instructional perspective today. So go ahead and get started on the assignment. It's found at my website. And give it a shot. Jot down any questions you might have. Bring them to class, and we'll get those answered for sure. All right. Take care. Good job.